Hello, dear student. Myself, dr.jaiswal, Head Department of Physics, Moreshwar College, Bhukargan, District Jalna. Today we will see numerical based on X-rays. Now see in example first. Calculate the longest wavelength that can be analyzed by a rock salt crystal of spacing d equal to 2.82 angstrom. Find the longest wavelength in the first order and in the second order. So we know that Bragg's equation, that is 2d sine of theta equal to n lambda. Therefore lambda equal to 2d sine of theta upon n. Now in the first order, that is n equal to 1 and d equal to 2.82 angstrom, that is given in our example, and theta equal to 90 degree for the longest wavelength. So lambda equal to 2 into 2.82 into sine of 90 degree upon 1. After simplification, lambda equal to 2 into 2.82 equal to 5.64 angstrom. That is the wavelength for n equal to 1. In the second order, that is n equal to 2, lambda dash equal to 2 into 2.82 into sine of 90 degree upon 2, and after simplification lambda dash equal to 2.82 angstrom. Now see, a beam of X-rays is incident on a sodium chloride crystal. Lattice constant equal to 2.82 angstrom. The first order Bragg's reflection from 110 plane is observed at a grazing angle of 7 degree 30 minutes. Calculate the wavelength of X-rays. Also find the angle at which the second and third order Bragg's reflection would occur. Now see, according to Bragg's law, 2d sine theta equal to n lambda. Therefore sine theta equal to sine of 7 degree 30 minutes, that is we get sine theta equal to 0.1305 and n equal to 1. So 2 into 2.82 into 0.1305 equal to 1 into lambda. Now therefore after simplification lambda equal to 0.736 angstrom. Now from Bragg's equation we have sin theta equal to n lambda upon 2d. For n equal to 2, sin theta equal to 2 lambda upon 2d, and therefore lambda upon d equal to, now putting the value of lambda, that is 0.736 upon d 2.86. After division we get 0.261, or sin theta equal to sin inverse 0.261, and that is equal to 15 degree 8 minutes. Now for n equal to 3, sin theta equal to 3 lambda upon 2d. and therefore that is equal to 3 into 0.736 upon 2 into 2.82 equal to 0.392, and therefore theta equal to sine inverse 0.392, that is equal to 23 degree 4 minute. Now see example, that is X-rays of wavelength 0.71 angstrom are reflected from the 110 plane of a rock salt crystal having the D equal to 2.82 angstrom. Calculate the glancing angle corresponding to second order reflection. Now the distance between consecutive lattice planes defined by Miller indices HKL in a cubic lattice is given by the HKL equal to A upon under root of H square plus K square plus L square, where A equal to 2.82 angstrom, H equal to 1, K equal to 1 and L equal to 0 for 110 plane. So therefore D 110 equal to A upon under root of 1 square plus 1 square plus 0, that is equal to A upon root 2 equal to 2.82 upon 1.41, that is the value of root 2, and so that is equal to 2 angstrom. Now from Bragg equation 2d sin theta equal to n lambda. So d equal to 2 angstrom, n equal to 2 and h lambda equal to 0.7 angstrom. So 2 into 2 sin of theta equal to 2 into 0.7, and therefore sin theta equal to 2 into 0.7 upon 2 into 2, that is equal to 0.355, and therefore theta equal to sin inverse 0.335 equal to 20 degree 42 minutes. X-ray beam of wavelength 0.797 angstrom is obtained in the third order after reflection at 60 degree from the crystal plane. Another beam is obtained in the first order after reflection at 30 degree from the same crystal plane. Find the wavelength of the second X-ray beam. Now, according to Bragg law, 2d sin theta equal to n lambda. Now, for the first X-ray beam, 2d sin 60 degree equal to 3 into 0.97 angstrom, and for the second X-ray beam of wavelength lambda dash, since D remains the same crystal, then 2D sin 30 degree equal to 1 into lambda dash. So dividing equation 2 by equation 1, we get lambda dash upon 2 into 0.97 equal to sin 30 upon sin 60, and therefore that is equal to 1 by 2 upon root 3 by 2 is equal to 1 upon root 3, and so lambda dash equal to 3 into 0.97 upon root 3, and that is equal to 1.68 angstrom. That is the value of lambda dash. Now an X-ray tube operated at 40 kilovolt emits a continuous X-ray spectrum with a short wavelength limit lambda minimum equal to 0.310 angstrom. Calculate the Planck constant. Now here we know V into E equal to H nu max, that is equal to H into C upon lambda minimum, because mu max equal to C upon lambda. So here H equal to V into E lambda minimum upon C, and therefore V equal to 40 kilovolt equal to 40 into 10 raised to 3 whole, and E equal to 1.6 into 10 raised to minus 19 coulomb. Therefore lambda minimum equal to 0.310 angstrom, that is equal to 0.31 into 10 raised to minus 10 meter, and therefore C having the value, that is C equal to 3 into 10 raised to 8 meter per second. So putting this value, H equal to 40 into 10 raised to 3 into 1.6 into 10 raised to minus 19 into 0.3 into 10 raised to minus 10 upon 3 into 10 raised to 8, and after division we get H equal to 6.61 into 10 raised to minus 34 joule second. Thank you.